The next problem is parallel RLC circuit. The question says the switch is closed at t equals to 0. Determine V dV by dt and d square V by dt square at t is equal to 0 plus. The diagram given is resistor, inductor, capacitor. So you have parallel RLC circuit. This is given as 10 ampere. Say this is 4 ohms. This is 10 Henry. This is 1 microfarad. The switch is closed at t is equal to 0. So initially the switch is open. So what I'll do, I'll find the circuit at t is equal to 0 minus. When t is equal to 0 minus, the switch is open. That means there will be no current flowing into this. So the current flowing through the inductor will be 0 and the voltage across capacitor will also be 0. So IL, that is current through the inductor, 0. Voltage across capacitor at 0 minus will be 0. And that is nothing but suppose V of t is given across this capacitor. So this is nothing but V of 0 minus also. Voltage across capacitor and V of t are same. Now whatever we have got at t is equal to 0 minus will be continued at t is equal to 0 plus. Since there will not be instantaneous change of current through the inductor will be 0 when the switch is just closed. Similarly, voltage across capacitor at 0 plus will again be 0. And the circuit for this t is equal to 0 minus, this will be, the switch is closed at 0, t is equal to 0, this will be open. And when t is equal to 0, that is this instant, the switch is just closed. Since there was no initial current through the inductor, it will be open circuited. Since there was no voltage across capacitor, it will be shorted. So this is the diagram for the circuit. Plus minus V of 0 plus, and this is current flowing through the inductor at 0 plus instant. This you have 2 ohms, and VC of 0 plus and V of 0 plus are same. Now we'll draw the circuit at t greater than 0. So the circuit for t greater than 0 will be the current source, the switch is closed, the resistor which is of 4 ohms, and this is 10 ampere, the resistance, then the inductor, then the capacitor. Capacitor is 1 microfarad, 10 Henry, 4 ohms. This is 10 ampere plus minus V of t. So what I'll do, find KCL at this point. So I can say 10 is equal to V by 4 plus 1 by 10 integral 0 to t V dt plus 1 into 10 raised to minus 6 dV by dt is equal to 0. So I can say at t is equal to 0 plus, voltage at 0 plus is 0. There is no integral or limit for this, so this term will also be 0. so you are left with only this term. So I can say dv by dt at 0 plus will be 10 upon 1 into 10 raised to minus 6. So this will be 10 raised to 7 volts per second. Now we need to find, so we have got v at 0 plus, which is 0, which is same as vc at 0 plus, and we have got dv by dt at 0 plus, which is 10 raised to 7 volts per second. Now I am calling this as equation 1. I'll differentiate equation 1 with respect to t. So it will give me, this will be 0 1 by 4 dv by dt plus 1 by 10 v, that is v of t you can write, plus 1 into 10 raised to minus 6 d square v by dt square is equal to 0. Now at 0 plus this is 0, so I can say 1 into 10 raised to minus 6 d square v by dt square will be minus 1 upon 4 dv by dt. I can say d square v by dt square is minus 1 upon 4 into 10 raised to minus 6 into dv by dt at 0 plus is 10 raised to 7. So the final answer will be minus 2.5 into 10 raised to 12 volts per second square. So we have solved the problem for, so this is minus 2.5 10 raised to 12 volt per second square. So we have found v, we have found dv by dt, and we have found d square v by dt square at t is equal to 0 plus. So this is how you need to solve the problem.